Assalamu alaikum, Hassan Termas from En Math Schools. Today we will start by part 2 from our lesson, Real Numbers. Objectives: solve equations of the form x power 2 equal a, where a is any number, expand and reduce algebraic expressions consisting of radicals, rationalize the denominator of a numerical fraction. We need the materials, textbook, papers, pen, and calculator. Let us start by square roots and equations. A is any number. If a is positive, greater than 0, then the equation x power 2 equals a admits two solutions. The first one is x equal minus radical a, or the second one is x2 equals to radical a. So we have two solutions for this equation where a is positive. But if a equals to 0, then the equation x power 2 equals 0 admits a unique solution, x equals to 0. This means that we have only one solution. If a is negative, less than 0, then the equation x power 2 equals a has no solution. Why? Because the squared number cannot be equal to a negative number. Therefore, this is impossible to find a squared number equals to a negative number. Let us take some examples. The equation x power 2 equals 25 has two solutions. The first one is minus radical 25, which is minus 5, or the second one, x equal radical 25 or 5. Notice that x squared equals to 25. So we move 25 to the left side and we get x squared minus 25 equals to 0. Then we write x squared minus 25 in this form, x minus 5 into x plus 5 equals to 0, according to this identity rule. A power 2 minus b power 2 equals a minus b into a plus b, where x is a and 5 is b. Then we say x minus 5 equals to 0, so x equal 5, or x plus 5 equals to 0, so x equal minus 5. The equation x power 2 equals to 7 has two solutions, x equal minus radical 7 or x equal radical 7. Since 7 is positive, and here we say if a is positive, then we have two solutions. The equation x power 2 equals to minus 7 has no solution since a is negative, and also we say here if a is negative, then the equation has no solution. This is the first application. Stop the video and try by yourself. Okay, and this is the solution. The first one, x power 2 equals to 8. 8 here is positive, so we have two solutions, x equal minus radical 8 or x equal radical 8. Then we simplify radical 8 inside the radical to find x equal minus 2 radical 2 or x equal 2 radical 2. The second one, 3x squared equal 5. We divide both sides of the equation by 3 to get x power 2 equals 5 over 3. Then x equal minus radical 5 over 3 or x equal plus radical 5 over 3, since we have a is positive, so we have two solutions. The third one, x power 2 plus 6 equals to 0. We move plus 6 into this side, then we have x power 2 equals to minus 6. This equation has no solution since a is negative. 4. 2x plus 1 all squared equals to 0. Then we get 2x plus 1 equals to 0. Then we solve the equation to find finally x equal minus 1 over 2, which is only one solution, and we call this is a unique solution. Now, expanding and reducing expressions consisting radicals. Let us expand the following expressions, and here we will use the remarkable identity rules. The first one we can expand it according to the first identity. A minus b into a plus b equals a power 2 minus b power 2. Here we have a is 3 radical 5 and b is radical 7. Because we have this form a minus b into a plus b, then we can write directly a power 2 minus radical 7 power 2, which is b power 2, equal to 45 minus 7, we have 38. The second one can be expanded according to the second identity, a minus b all to the power 2. So we have here a is 2 radical 6 and b is 1. According to this identity, we can write 2 radical 6 power 2 minus 2 times a, which is 2 radical 6, times b, which is 1, plus b power 2, which is 1 power 2. And then solve and calculate to find 25 minus 4 radical 6. The third one also can be expanded according to the third identity. We have 4 radical 2 is a and radical 5 is b, and then expand according to the identity to find the expanded form 37 plus 8 radical 10. Part 4. Here we cannot use any of these identities, so we can expand manually. So first we multiply minus 2 radical 3 by radical 3 to find minus 6. And then we multiply minus 2 radical 3 by minus 1 to find 2 radical 3. Then multiply 5 by radical 3 to get 5 radical 3. Finally, we multiply 5 by minus 1 to get minus 5. And we can simplify here and calculate to find the answer minus 11 plus 7 radical 3. Here, application 2. Stop the video and try to solve. Okay, the solution. Part 1. Here we expand manually. 2 radical 5 times radical 15. And then 2 radical 5 times minus 3. Then we have 2 radical 5 power 2 times 3, because 15 is 5 times 3. And when we multiply 5 by 15, so we will get 5 power 2 times 3. Then minus 6 radical 5 when we multiply 2 radical 5 by 3. Finally, we reduce to get 10 radical 3 minus 6 radical 5. Here, we cannot subtract these two terms because we have unlike radicals. Part 2. This expression in the form a plus b all to the power 2, we can use the remarkable identity to find 75 plus 12 radical 21. The third one, also, it is in the form a minus b into a plus b, so we can use the difference of two squares identity to find the answer, which is 5. The final one, we use first the remarkable identity for the first part, which is radical 6 minus 2 all square. And then for the second one, we can expand manually to find 18 minus 3 radical 6. Then we reduce and calculate to find the answer 28 minus 7 radical 6. Now we will talk about conjugate numbers. What are the conjugate numbers? Here we have two numbers. The first one is a plus b radical c, and the second one is a minus b radical c. These numbers are two conjugate numbers. Why? Because here we have plus, but here we have minus. Pay attention that a has the same sign in both numbers, but we change only the sign of b radical c. Let us illustrate this meaning and this concept by some examples. The conjugate of 5 minus radical 6 is 5 plus radical 6. We change only the sign of radical 6. The conjugate of 3 radical 2 plus radical 5 is 3 radical 2 minus radical 5. Also, we change only the sign of radical 5 from plus to minus. The conjugate of radical 7 is minus radical 7. Also, we change the sign of radical 7 from plus to minus. 2 radical 3 and minus radical 3 are not conjugate numbers. Let's start by this application. Stop the video and try by yourself. Okay, what is the conjugate of minus 3 radical 5? It is plus 3 radical 5. And we multiply these two numbers to get minus 45. The conjugate of radical 7 minus 2 is radical 7 plus 2. Here we change the sign of 2. Of course, we can keep the sign of 2 minus, but change the sign of radical 7. Here you can choose any number of these two numbers to change its sign, and not necessary to change the sign of 2. Then we multiply these two numbers and get 3. The conjugate of 5 radical 2 plus radical 3 is 5 radical 2 minus radical 3. Also here we change the sign only for radical 3 and we keep the sign of 5 radical 2. And then we multiply to get 47. The conjugate of minus radical 3 minus radical 6 is minus radical 3 plus radical 6. Here also we change the sign of radical 6 from minus to plus and we keep the sign of radical 3 minus. Of course, we can keep the sign of radical 6 minus, but to change the sign of radical 3 from minus to plus. And then finally we multiply these numbers to get minus 3. Now we will talk about rationalizing the denominator, which depends on the conjugate. We speak about it previously. To rationalize the denominator of numerical fraction, this means that we should remove the radical from the denominator. To do that, we multiply the numerator and the denominator by a conjugate of a denominator. Let us see. To rationalize the denominator of radical 2 over 3 plus radical 2, we should remove the radical from the denominator in this fraction. To do that, we multiply the numerator and the denominator by 3 minus radical 2, because it is the conjugate of 3 plus radical 2. So we multiply by 3 minus radical 2 in the denominator and in the numerator. We expand in the numerator and we make identity in the denominator to get 3 radical 2 minus 2 over 7. The second example, to rationalize the denominator of 3 over 2 radical 11, we should multiply the numerator and the denominator by minus 2 radical 11, because it is the conjugate of 2 radical 11. And when we multiply both terms of the fraction, we will get 3 radical 11 over 22. Pay attention here. Since we have 2 radical 11 in the denominator, in the form of a radical b, we can multiply only by radical b, which is radical 11 in this case, to get the same answer, 3 radical 11 over 22. This application is for you. Try by yourself and stop the video. Okay, let's start by the first one. The first one of denominator a radical b in this form, so we can multiply by radical 2 only to get radical 10 over 3. Here we have a plus radical b or radical b plus a. It is not different, so we can multiply by the conjugate radical 3 minus 2 in the numerator and denominator and make some calculations to get minus 7 plus 4 radical 3. Notice here we have a number divided by minus 1. Then when we divide by minus 1, we change the signs of the numerator. Here we have 7. Then when we divide by minus 1, we get minus 7. Here we have 4 radical 3. And when we divide by minus 1, we get 4 radical 3. Finally, we multiply by the conjugate 7 radical 2 plus 2 radical 7 in the numerator and denominator, and then we get 7 radical 2 plus 2 radical 7 over 70. Here your assignment, and this is the summary of this video and the previous video, part 1. And thank you for watching. Assalamu alaikum.